Hello everyone, welcome to Mathworld. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 5, which is a Probability and Statistics 1 for October-November 2020, and the code is 9709/53. So let's get started. Question number 1. The times taken to swim 100 meters by members of a large swimming club have a normal distribution with mean 62 seconds and standard deviation 5 seconds. A. Find the probability that a randomly chosen member of the club takes between 56 and 66 seconds to swim 100 meters. So same 100 meters here. Okay, so now I will write X is normally distributed with mean 62, standard deviation 5. So variance will be 5 squared. And now we need to calculate probability is between 56 and 66 seconds. So P between 56 and 66 seconds. So here 56 and 66. Now, when you are given normal distribution, we need to standardize it using a formula x minus mu over sigma. That means now this is going to be P 56 minus 62 over 5. And the other one is 66 minus 62 over 5. Then from here, I will be getting minus 1.2 and 0.8. Okay, so now from here, I will sketch the graph to show two lines. One is negative 1.2, another one is 0.8. This is the region bounded by the two lines. Now, since there is a negative value here, I will just use PZ less than 0.8 minus PZ less than negative 1.2. So, but then to get the negative PZ less than negative 1.2, then I need to sketch another graph. So negative 1.2, I can just flip to the positive side. Okay, so when I flip, it will be greater than 1.2. So then this will be 1 minus PZ less than 1.2. So this is PZ less than 0.8 minus 1 minus PZ less than 1.2. Okay, then here I will be getting 0.7881 minus 1. The minus, you bring it in, it will be plus. Right, 0.8849. So just get these two probabilities from the table. Just read it from table. Then lastly, you will be getting 0.673. So this is the solution of this A. Now, part B, 13% of the members of the club take more than T minutes to swim 100 meters. Find the value T. Okay, so now let's look at the question. This is seconds, right? All these are seconds. And now you are given T minutes. So T minutes equals to 60 T seconds. Okay, so because my mean and standard deviation are in seconds, so I change the T minutes into seconds, that it will be easier. So it's mentioned that X greater than 60 T seconds with 0.13 probability. 13% you convert to probability is 0.13. So now you standardize it. So it will be 60 T minus the mean remains the same. 62 standard deviation is 5. So minus 62 over 5. This is 0.13. Then from here, I will be getting, okay, now right after this, we need to sketch a graph. So I will sketch a graph over here. And I'm not sure where is this line. So you can just draw two lines, one on the left side, and label this as 60T minus 62 over 5. And then here is greater than, means from the line onwards. Okay, label here 0.13. So obviously this is not possible because the region above 0, mean the probability of z more than 0 is already 0.5. So when I let my line be on the left side of 0, but then the probability is less than 0.5. This is not correct. Therefore, now I need to change my line. My line should be on the right hand side. Okay, obviously it's on the right side. Then here is 0.13. So this is 60t minus 62 over 5. Alright, so now from here I know that since my line is on the right side, which means this is positive, so now my region to the left side here, it will be 0.87. Right, so from here I will just say P z less than 60t minus 62 over 5 equals to 0.87. So now from table, since the line is on the right side and the region is towards left hand side, then I can just refer to table, the normal table, to get the critical value. That is z less than 1.127 to get 0.87 probability. So now I will compare, okay, compare these two values to get the t. So then 60t minus 62 over 5 equals to 1.127. So to get the t, just move the 5 to the other side and then move the minus 62 to the other side as well. So it becomes 60t equals to 5 times 1.127, then followed by moving the minus 62 to right side, it becomes plus 62. Okay, then my t just divide by 60. So it will be 5 times 1.127 plus 62 over 60. Then this is going to be 1.12725. And at last, round up to 3 significant figures. So look at the fourth significant figure. This is more than 5. Then you round up. It will be 1.13. That's the t value. Okay, now question number 2. An ordinary fair die is thrown until a 6 is obtained. So whenever you say until a success, this is geometric distributed. Okay, now A, find the probability that obtaining a 6 takes more than 8 throws. So now P, x greater than 8. So greater than 8, I can say it is 1 minus P, x less equals to 8. Use the complementation rule. Now for your information, if your x is geometric distributed with P, okay, or just write G here, G means geometric distributed with P, probability that x less equals to small x, it will be 1 minus q to the power of x. So now a fair die to get 6, so which means the probability of getting 6 is 1 over 6, which means my P is 1 over 6, then my Q is 1 minus 1 over 6 to get 5 over 6. So now, by applying this formula, it will be 1 minus my Q, 5 over 6 to the power of 8. So when you open the brackets, times in the minus, alright, so here I will get 1 minus 1 plus 5 over 6 to the power of 8. So at last, you will be getting 0.2326, and this round up to 3 significant figures. This will be 0.233. Okay, now two ordinary fair dice are thrown together until a pair of 6 is obtained. The number of throws taken is denoted by the x. Find the expected value of x. Alright, so now if you need to get both 6, alright, 6 and 6, that means it will be 1 over 6 for the first dice and 1 over 6 for the second dice. So here becomes 1 over 36. That means my P is 1 over 36. Okay, because until a pair of 6 is obtained, that means this is still geometric distribution. Now, the expected value for geometric distribution, Ex, is 1 over P. Okay, so now I will get Ex is 1 over 36, which is 36. Means that you need to throw 36 times to get a pair of 6. Now see, find the probability that's obtaining a pair of 6 takes either 11 either 10 or 11 throws. So if 10 throws means that first 3, okay, so here I will write 10 or 11 throws. So if 10 throws means that first 9 throws, not 6. Okay, not pair of 6. Not a pair of 6. Or is plus. 11 throws means first 10 throws, not a pair of 6. Right, so when first 9 throws not a pair of 6, so we know that a pair of 6 is 1 over 36. Alright, so P equals to 1 over 36. So then probably I will just write here P, a pair of 6, is 1 over 36. So means the Q is 35 over 36. So from here, I will get first 9 will be 35 over 36. And then last one is 1 over 36. Or first 10 with 35 over 36 probability. And then the last one is 1 over 36. Then from here, when I calculate, the first one is going to be 0.02156 and the second value is 0.02096. So when you add up both values, it will be 0.04252 and round up to 3 significant figures. For the final answer, it will be 0.0425. So that's the solution for part C. Now for question number 3. A committee of 6 people is to be chosen from 9 women and 5 men. A. Find the number of ways in which 6 people can be chosen. Okay, chosen if there must be more women than men on the committee. So now you have 9 women, 5 men, and now you need to choose 6. So if you need to get more women than men, I may have 6 women, okay, or I can have 5 women, 1 man, then 4 women, 2 men. Alright, so now to get 6 women, it will be 9. So here, number of ways. It will be 9, choose 6, all is plus. Then 5 women, 9, choose 5, and 5 men, choose 1. Okay, or 9 women, choose 4, and 5 men, choose 2. Then from here, you will get 84 plus 630 plus 1260. Then at last, you will be getting 1974. That is the number of selection. Okay, now the 9 women and 5 men including a sister and brother. B. Find the number of ways in which the committee can be chosen if the sister and brother cannot both on the committee. So, which means now you have 9 women and 5 men. So here you have 1 sister, okay, and then 8 others. 1 sister, 8 others. And then for the 5 men, you have 1 brother and 4 others. Okay, so now you need to choose okay, how many we need to choose? We need to choose 6. Right, we need to choose 6. So from here, you choose 6. Now, if given that brother and sister cannot be both on the committee, which means now probably sister is chosen, brother is not. Okay, so brother is not. So now, then I have only chosen 1, so I have to choose 5 others. Alright, so probably sister is not chosen, the brother is chosen, then I have to choose another 5. Or probably both of them are not chosen, because it's mentioned that cannot be both. Alright, cannot both be on the committee. So sister is not chosen, brother also not chosen, so I have to choose 6 others. So now, how do we choose this? Okay, so basically, when you look at this, right, so I know that I will have 12 others. This one plus together is 12. So if sister is chosen, so one way. So 1, choose 1. Brother is not chosen, just don't bother. I need to choose this 5 or this from the 12. So it means that it is 12C5. Okay, all these are all. All is plus. Brother is chosen, so 1, C1, and 12 choose 5. Or both sister and brothers are not chosen, so I have to choose 6 from the 12. Okay, then from here, I will be getting 792 plus 792 plus 924. So at last, that is 2508. That is the solution of this question. Okay, now question number 4. The 1,300 train from Johor to Kerman runs every day. The probability that the train arrives late in Kerman is 0.35. For a random sample of 7 days, find the probability that train arrives late on fewer than 3 days. So this is binomial distributed. B is 7 days. Coming late, arriving late is 0.35. Okay, that means P is 0.35. The Q is 1 minus 0.35, which is 0.65. Now, since this is binomial distributed, this is the formula. Probability of x equals to lowercase letter x, it will be NCX, PX, QN minus x. That means now you need to get less than 3 days. So Px less than 3. Less than 3 means your x will be 0 or 1 or 2. Okay, so when Px equals to 0 means no late. No late means all punctual. So 0.65 to the power of 7. Then out of 7 days, 1 late. So 0.35 degree 1 and then 0.65 degree 6, or 7C2, 0.35 degree 2, then 0.65 degree 5. Then from here you will get 0.04902 plus 0.18478 plus 0.29848. So then you will get 0.53228, and now round up to 3 significant figures, that is 0.532. So that's the solution for 4A. Okay, now a random sample of 142 days is taken. B. Use an approximation to find the probability that the train arrives late on more than 40 days. So now, initially, it is 142 days. Arriving late is 0.35. So now, because your n is large, which is 142, so now I have to approximate to normal distribution. So NP is 142 times 0.35, and this is going to be 49.7. Then now the variance NPQ, I will get 49.7, which is my NP, times with the Q, 0.65, and you will be getting 32.305. And now from here, this binomial distribution will be approximated to normal distribution. And the mean is 49.7, and then the variance is going to be 32.305. And now you need to calculate probability that arriving late is more than 40 days. So Px greater than 40. Now, be careful with this question because you were given binomial. Okay, binomial is basically discrete. And now you approximate to normal. This normal is continuous. So from discrete to continuous, you need to consider the continuity correction. Okay, which means now you label 40. Greater than 40 means that you accept 41, 42, and so on. But then since it is the continuity correction factor is needed, so therefore you have to plus and minus 0.5 from the given x, which means either 39.5 or 40.5. But then since this is greater than 40, that means you have to consider the directions to the right side, which means from here to include the ticks, right, you need to consider greater than 40.5. So from here, I will change to another notation, which is the variable of W, greater than 40.5. So now you standardize it. Okay, so standardize it using the same formula, 40.5 minus the mean. Mean is 49.7 over standard deviation means square root of 32.305. Then from here, you will be getting z more than negative 1.619. Okay, then from here, after you have found the z, right, you have to sketch a graph to see the region. So my line is negative 1.619. And then since this is greater than, therefore the region is towards right side. And now from here, I need to flip my graph. Okay, because the region is on the, the line is the negative. Negative is not available in the table. So I reflect it at the line equals to 0. Then now my region also reflected. So this region is basically z less than 1.619, and it is available in the table. So now you just need to read the probability from the table. That is 0.9472. And now I round up to 3 significant figures. That is going to be 0.947. So this is the solution of this question. Okay, now for question number 5. The 8 letters in the word reserved are arranged in a random order. A. Find the probability that the arrangement has V as the first letter and E as the last letter. So now RESERVED. So from here you have 8 letters. Out of 8 letters we have 2 R. Okay, 2 R's. Then we have 3 E's. After that we have S. And then we have V and D. Okay, now V as a first letter and then E as a last letter. So it means 8 letters here, you still have 6. Out of these 6, okay, look at here. V is taken, one E is taken, that means you still have 2R and 2E. Okay, so V and E we cannot swap. Alright, no more arrangements for these two letters. So just arrange the middle values, the middle letters. So basically this is probability. Okay, now for probability we need to divide by the NS. So now basically when I need to get V as a first letter and E as a last letter, I have to arrange 6 other letters. So which is 6 factorial, but out of 6 factorial, out of these 6 letters, there are 2 R's. So divide by 2 factorial. So I will write here 6 factorial over 2 factorial for 2R and another 2 factorial for the E's. Then divide by, okay, in general, it will be 8 factorials because 8 letters, but out of 8 letters, I have 2R and 3 E's. So divide by 2 factorial and 3 factorial. This will be my working. And then now you will be getting 180 divided by 3360, which is 3 over 56. So that's the solution of 5A. Okay, now B, find the probability that the arrangement has both R's together, given that is conditional probability, all 3 E's are together. So P, 2 R's together, given that 3 E's together. Okay, so I just write in this form. Alright, so that means it will be probability of 2 R's together and 3 E's together over P 3 E's together. Okay, so now remember just now we have 2R 3 E's SVD. Okay, so we have 2R 3 E's SVD. Now if 2 R's together, okay, I put them in a group, 3 E's together, so I still have SVD here. That means, right, the first one, 2 R's and 3 E's together, which means now I treat this as 1, then this is 2, this is 3, 4, 5. So when they are together means that I need to arrange this 5. So 5 factorial over when 3 E's are together. Okay, 3 E's are together means that I still have, remember just now 8, right, total, here 8. So out of 8 I minus 3, I still have 5, but this 5 I have 2 R's. Okay, then SVD. So it means that when I need to calculate probability of 3 E's, so I will just, you look at here, I skip one step already. So supposedly it's like this. It is n of 2 R's and 3 E's. Okay, they are together over ns, because that's a definition for probability, then divided by n of 3 E's are together, then over ns. So now since it is the same experiment, ns will be the same. That's why I cancel off the ns. Then now here you will just need to consider how many arrangements to get 2 R's together. Okay, and 3 E's together. Then over n of 3 E's together. Okay, so now for the 2 R's and 3 E's, just now I've mentioned here, it will be 5 factorial because I treat 2R as 1, 3E as 1, and they are identical R and E. Therefore, there's no difference. Okay, no need to arrange. So my probability of 2 R's slash 3 E's, it will be, okay, 5 factorial over 3 E's will be, treat the 3A as 1, okay, then here you have 5. That means now it will be 6 in total, okay, 1 plus 5 is 6. So I arrange these 6 letters, but out of 6 I have 2 R's, so I have to divide by 2 factorial. Therefore, this is going to be 120 over 360, and at last you are getting 1 over 3. So that is the solution of this question. Okay, now question number 6. 3 coins A, B, and C are each drawn once. Coins A and B are each biased, so that the probability of obtaining a head is 2 over 3. C is biased, the probability of obtaining a head is 4 over 5. A, show that the probability of obtaining exactly 2 heads and 1 tail is 4 over 9. Okay, so here I will write P head from A is same as P H from coin B equals to 2 over 3. That means P T A, T means tail, equals to P T B equals to 1 over 3. Okay, same goes to the coin C. Head of C is 4 over 5. That means to get the tail from coin C, it will be 1 over 5. Now, because each one thrown once, so 2H, 1 tail. So now P 2H, 1 tail. So now I have to consider this 1 tail is from which coin? Coin A, coin B, or coin C. So this is same as P HA, HB, TC. Okay, that means the tail is from C. Probably it can be HA, TB, and then HC. Or P, TA, HB, and then HC. Okay, so all the coins are independent to each other, so just times. HA, HB will be the same, 2 over 3. TC is 1 over 5. So now, 2 over 3, TB is 1 over 3. Then HC, it will be 4 over 5. And the TA is 1 over 3. HB is 2 over 3 from the information here. HC is 4 over 5. Okay, so from here, I know that the denominator 3 times 3 is 9. 9 times 5, 45. So here over 45. So 2 times 2 is 4. And then 2 times 4 is 8. And 2 times 4 is 8. Therefore, this is 20 over 45. And now when you simplify, divide by 5 for numerator and denominator, that will be 4 over 9. Okay, so we have shown the probability 4 over 9. Now, the random variable x is the number of heads obtained when 3 coins are thrown. Draw up the probability distribution table for x. Means that now you are throwing 3 coins, so it can be no head, 1 head, 2, and 3. So since we have counted just now 2H, 1T, okay, so means that now I can find no H. So P0H. P0H means that you are getting all tails. So PTA, TB, and TC. So tail A, tail B, tail C, THTB is 1 over 3. TC is 1 over 5. So I will just times 1 over 3 times 1 over 3 times 1 over 5. This is going to be 1 over 45. Okay, now I calculate P3H. P3H means HA, HB, HC. So HA, probability of HA is 2 over 3. Same goes to the HB. So 2 over 3 times 2 over 3 times HC will be different. That is 4 over 5. So you multiply by 4 over 5. This is going to be 16 over 45. So now this PH0H means that this is Px equals to 0. Okay, P3H, this is Px equals to 3. Right? So pH equals to 2 already found here. So now pH equals to 1. So Px equals to 1 is basically, probably I will just write down first. This is 4 over 9. So 4 over 9 I can change to 20 over 45. So Px equals to 1 means 1 minus all the rest. So 1 over 45 plus 16 over 45 plus 20 over 45. That means this is going to be 8 over 45. Okay, then now I just put put all these values in a table. So this will be the x and the probabilities. So my x is 0, it will be 1 over 45, where x equals to 1, that will be 8 over 45, where x equals to 2, 20 over 45, and then where x equals to 3, 16 over 45. Okay, so this is the table probability distribution of x. Okay, now Passy, given ex is 32 over 15, find the variance x. So now ex squared equals to summation x squared times p. So refer to the table. Okay, so I square the x, so 0 squared times 1 over 45 plus 1 squared times the probability is 8 over 45 plus 2 squared times the probability is 20 over 45 and then followed by 16 over 45. 20 over 45 plus 3 squared 16 over 45. Then from here, this is 232 over 45. Okay, so lastly, variance x is ex squared minus square of the expected value. So this is going to be 232 over 45 minus the ex is 32 over 15. So this is going to be 136 over 225. So that's the solution of this variance. Okay, now question number 7. A particular piece of music was played by 91 pianists, and for each pianist, the number of incorrect notes was recorded. The results are summarized in the table. So you are given the table. A. Draw a histogram to represent this information. So for histogram, we need the frequency density because it is not equal class width. Okay, so what I need to do here is I just copy back this table. Okay, or probably I just add on here. Just add on. So first of all, I need to find out the class width, which is a C. So class width is basically average of these two values, which is 5.5, the boundaries, minus, now when you look at here, 5 and 6, the previous one should be 0. So it will be 0.5, get the average, then this is 5.5. So when you minus, I get 5. Okay, same goes to the next one. This is going to be 10.5. So 10.5 minus 5.5, it is 5. Then this is 20.5. So 20.5 minus 10.5, I get a width of 10. This is 40.5. So when you minus, you get 20. The next one is expected to be 71. So when you get the average, it is 70.5. Then you minus, you get 30. Now, here I need to get frequency density. That is FD, which is F over C. My F is a frequency. So when you divide 10, divide by 2, divide by 5, this is 2. 5 divided by 5, this is 1. Okay, so 26 divided by 10, 2.6. 32 divided by 20 is 1.6. 18 divided by 30 is 0.6. Now here, my, what is that called? The histogram needs the boundaries. Okay, so I will just write down my boundaries, 5.5, 0.5, and all this. So all this will be my boundaries. right? So my vertical axis is up to 2.6. Therefore, okay, I will just draw like this. This is my class boundaries, or probably you just label this as number of incorrect nodes. Okay, then vertical axis will be the frequency density. So please use ruler to draw this. Right, I need 2.6. Probably I will let this be 0.5, 1, here is 0.5, 1.0, 1.5, 2.0, 2.5, 3.0. So maximum is just 2.6. So I will stop here. This is my frequency density. Okay, so now for my horizontal axis, since it's 0.5 until 70.5, then I will label this as 0.5. Then here is 10.5, 20.5, 30.5, 40.5. So just continue until 70.5. Okay, so now we need to mark from 0.5 to 5.5 okay, now you look at here. Look at this together with the boundaries that I've counted just now. So 0.5 to 5.5, the height is 2. 0.5 to 5.5, 5.5 is here, is 2. So right, and then the next one is 5.5 to 10.5 is 1. Okay, then the next one is going to be 10.5 to 20.5. The height is 2.6. So 2.6, this is 2.5, 2.6 is over here. Until 10.5, until 20.5. So please draw all these histograms using ruler. Okay, then the next one is 20.5 to 40.5 is 1.6. So 1.6, so here is 1.6 until 40.5. Okay, then 40.5 to 70.5, it is 0.6. So 0.6, here 5, 6. So this is your histogram. Right, so now next part, state which class interval contains the lower quartile, which class interval contains the upper quartile. Hence, find the greatest possible value of the interquartile range. Okay, so we know that lower quartile, Q1 is 1 over 4. Okay, now look at the total first. the total is 91. Okay, 91 playlist, because this is group data, so just times 91. No need to add plus 1. So this is 22.75. Alright, so that means my Q1 class. Okay, now to get this Q1 class, I need to know the cumulative frequency. So therefore, in this table, I need to add one more, which is capital letter F, cumulative frequency. Which is a capital letter F. So capital letter F is just add up. So it's 10. 10 plus 5. Okay, this 10 plus 5, it will be 15. 15 plus 26, it will be 41. 41 plus 32, you will get 73. 73 plus 18, okay, you plus 18, it will be 91. Okay, so now when you look at the calculation here, my Q1 is the data with 22.75 position. So which means, right now look at the capital F, which class will have this position, or which class will have this data. So 22.75, that means it will be in 11 to 20, because this means you will have data 1641, because the previous up to data 15. So I will get the class 11 to 20. So now my Q3 is 3/4 of the total. This is same as 68.25 data. So now my Q3 class. Okay, let's check which class will contain this data. 68.25. That means obviously 68 is between 42 and 73. Therefore, this is my Q3 class, 21 to 40. So 21 to 40. Okay, now you need to find greatest possible value for interquartile range. So greatest possible, or greatest IQR, interquartile range. Right? So it will be the biggest minus the smallest. So 40 minus 11, which is 29. Because the interquartile range, the interquartile range is basically the Q3 minus Q1. Alright, so we take the, because now you need to get the greatest interquartile range. So we take the highest Q3 minus the lowest Q1. Now see, calculate the estimate for mean number of incorrect nodes. So for mean number, we need to get the midpoints. So now I need to calculate first. Midpoints. M, and then frequency F. So how do I count the midpoint? Midpoint is basically get the average. Okay, get the average of these two numbers. So 1 plus 5, 6. 6 divided by 2, you get 3. So that is how we count the midpoints. So that means here I will get 3. Okay, then the F I will just copy. Now the other one still the same method. Okay, so just get the average. So here 16 divided by 2, then get the average, and so on. So now I will just write down all the averages, right? All the midpoints. So 8, then 15.5, and then 30.5, followed by the last one is 55.5. Then the frequency will be 5, 26, 32, and 18. So now my mean is summation Fm over summation f. That means you just multiply f and m. So it will be 3 times 10 plus 8 times 5 plus 15.5 times 26 plus 30.5 times 32 and then plus 55.5 multiplied with 18. Then divided by the total f. Total f is basically 91. Okay, then from here you will get 2448 over 91. Then you will be getting 26.9. So that's the mean. Okay, so that's all for this video. Thanks for watching. Please like this video and subscribe to the channel, and also share it with your friends if you enjoy watching my videos. And also stay tuned for more upcoming videos. Thank you. Bye.